Hi, and welcome to our first flipped classroom lesson over 8.2 Arithmetic Sequences and Series. Now remember, this replaces our lecture portion of our classroom experience, so make sure that you have a notebook and something to write with. Okay, here we go. The last 2 days in class we've been looking at all different types of sequences, and we've been strategizing and using trial and error to come up with their nth term definition. We've been using things like factorial and remembering how to make something oscillate, not something but a sequence oscillate by using -1 to the nth power, -1 to the nth plus 1 power. We've been using things like a sub n equals n squared, maybe a sub n equals n cubed minus 1, and we've been really working hard on trying to find why certain sequences do certain things so that we can define them. And so today is going to be a great relief, hopefully, for you guys, because we're going to be looking at a certain type of sequence. And what I've got right here on the board are 3 sequences, and they all share the same commonality. They all have something, some rule that they follow. And so what I want you to do right now is press pause and go ahead and see if you can figure that out. Okay, now hopefully you've taken the time to look and you notice that what's the same about all 3 is that they go up by a common value. For instance, with this first one, it's going up by 3. 1 plus 3 is 4, 4 plus 3 is 7, 7 plus 3 is 10, 10 plus 3 is 13. This next one's going up by 4, this next one's going up by 2s. And so when we notice that, when we look at a sequence and can identify that it's going up by a common number, by a common difference we call it, then we know that we're dealing with an arithmetic sequence. And when we can recognize and identify that a sequence is arithmetic, it makes things so much easier, and I'll tell you why in just a second. Okay, so when we see an arithmetic sequence like this first one, we're going to know that we can use a rule. And that rule is a sub n equals dn plus a sub 0. And so we already are familiar with this a sub n standing for an nth term definition. And we can even be familiar with a sub 0 because we can know that, hey, if this is a sub 1, then the one before it, which we don't see right now, is a sub 0. The only thing we absolutely know what n is, n stands for the term number. For instance, this is my first term, that's my second term, that's my third term, so we know what n is. The only new thing today is we're really looking at d, which stands for the common difference. And the common difference in this, once again we talked about this, we're going up by 3s. So, to define this sequence, we're going to have a sub n equals 3n. And then a sub 0 is just going to be, well, if the sequence is going up by 3s as we're progressing, if we go backwards, it's going to be going down by 3. So 1 minus 3 is going to give you -2. Voila, we have defined this sequence. A lot better than guess and check, isn't it? Okay, so now we've got a new sequence. Once we identify it as an arithmetic sequence, we're going to go ahead and define it. So I want you to be able to do that. And so go ahead and put it on pause so that you can do this in your notebook, and then we'll go through it together. Okay, so we're back from pausing. At least I hope you paused. Here we go. We're going to notice once again that we're going up by 4s, and so that's going to be my common difference. So I once again remind myself that this is the definition of my arithmetic sequence, and so my common difference is 4, and a sub 0 is going backwards, and so that means 3 minus 4 is -1, and we're done. Okay, let's try one more. So we're going to look at this sequence. It looks a little bit different because it is a descending, decreasing sequence, and so what I want you to do is go ahead and pause and write it down and attempt it on your own, and then we'll come back. Okay, so once again, we're just going to see what is the common difference. In this case, the common difference is going to be negative because 15 plus -5, 10 plus -5, So we know that our common difference is -5. And so the tricky part about this one really comes when we're doing a sub 0. And so if we're subtracting 5 moving to the right, we're going to be adding 5 moving to the left. So it'll be plus 20. Okay, so now we're ready to move on to the next part of the arithmetic sequence and series lesson. We're going to be looking at problems like this. If the fourth term of an arithmetic sequence, that's AS, is 20 and the 13th term is 65, find the nth term definition. So basically the first thing that I do when I see a problem like this is I want to get rid of the words. And so when I see the fourth term is 20, I'm going to write a sub 4 is equal to 20. The 13th term is 65, so a sub 13 equals 65, and they want me to find a sub n equals dn plus a sub 0. There are a couple different ways to go about doing this. A lot of people like to do this logically. I'm going to wait a second so that you can pause this and get this down on your notebook, and then we'll look at one method that we could use to solve this. So one way to look at this problem once we set it up is to look at a visual. If 20 is our fourth term and 65 is our 13th term, I thought I'd set this up so we could see that in between 20 and 65 we have, 9 even jumps to get from 20 to 65. And each of those jumps are going to be by the same number. And so logically we can say, all right, we've got 9 jumps, and 65 minus 20 is 45. So somehow, we went up 45, the value of 45, and we did that 9 equal times. So we're just going to divide it by 9 to see that our common difference is 5. Some of you may not need that visual, and you could just logically do this. So we know now that our common difference is 5, and what's left is to find a sub 0. With this one, we could go ahead and say, all right, we've got 20, that's my fourth term, third term, second term, first term. There's a sub 0 right there. So each time we're going to be subtracting 5, so we'll have 15, 10, 5, and 0. So, a sub 0 is 0, which leads us to the answer, a sub n equals 5n. Once again, there's a couple different ways to go about this, and as long as you end up with the right nth term definition, all is well. Okay, so another type of problem that we're going to see is like this one. Find the 10th term of an arithmetic sequence when the first term is 8 and the common difference is -2. Once again, when I see a word problem, I'm going to get rid of the words. I'll be doing that all year with you guys every time we face one of these. So it says find the 10th term of an arithmetic sequence. That means we're looking for what a sub 10 is. The first term is 8, and the common difference, d, is -2. There's a couple different ways we could go about this. One of them is the way I'm going to do it. And so I'm looking and saying, oh, thank you for giving me the common difference, is -2. So I'm going to go ahead and write down -2n. And then the only thing I have left to find is a sub 0. They gave me a sub 1 is 8. I know that since the common difference is -2, that means as I'm moving forward in the sequence, I'm subtracting 2. As I move backwards, I'm adding 2. So if 8 is a sub 1, then 8 plus 2, 10 is going to be a sub 0. Once I have my nth term definition, then I'm going to go ahead and use that to find my 10th term. So I'll have a sub 10, which means the 10th term, is equal to -2 times 10 plus 10. So that's going to be -20 plus 10, that'll be -10. And so that means my 10th term is -10. Okay, and so the last type of problem that we're going to be looking at today are partial sum problems. Like this one, find the fifth partial sum of the sequence 5, 16, 27, 38, and 49. And I know what you're thinking. Well, let's just go ahead and add all 5 together. And you're right, we'd get the correct answer. But one of his problems said find the 50th partial sum of the sequence, or the 500th partial sum of the sequence. Not so easy to just go ahead and add them up by hand. So the great news is that once you identify that you have an arithmetic sequence, it comes with its very own partial sum formula. And that partial sum formula is given by this. S sub n, which says we're taking the sum of a certain amount of terms, is equal to whatever the amount of terms is, divided by 2, times the quantity of the first term in the sequence, plus the last term that we want to add. So in this case, we're talking about looking for the first 5 partial sums, or the sum of the first 5 terms. And so 5 is going to be our n all the way through. So we'll have 5 divided by 2. Our first term is 5. In this case, our last term is 49. We didn't have to do very much work there. Some of the problems in our book when we get to class are going to be a little bit more difficult than this, but you'll have the tools to find that last term. We'll have to go back in and find the nth term definition. So we're looking at this, and let's see, if we do the math, we've got 54 divided by 2 is 27 times 5. So the answer is 135. Okay, so what you got in these minutes of this video online was the core of the lesson, which prepares you to come into class and be ready to attempt these problems. I'll be there, Ms. Carrier will be there, our peers will be there. We'll be working and building on this core part. So your responsibility is to come in with this core knowledge so that we can build on it and have some fun. So thank you for joining me.